Morning. Today we'll discuss about the basic terms which we use in the course of basic electrical engineering and also the different network elements which we come across in this course. I hope that by the end of this lecture you will be able to define the common electrical terms like the current, voltage, electrical energy, electric power, network, circuits, and the different components in a network. And also, I hope that you will be able to compare the properties of different network elements. So, I'll start with the common electrical engineering terms, a quick revision of what you have studied in your plus 2, and then will move on to the network elements, and finally, we'll discuss the properties of network elements. So, coming to the common electrical engineering terms, the common word which you might be listening in electrical engineering or electronics engineering is the current, electric currents. You might be knowing about the concept of charge, electric charge, right? Everything in this universe is made up of atoms, and atoms, they do have positively charged particles and negatively charged particles, and also there are uncharged particles, which means that we are made up of charged particles, and the positive charges are generally represented by the protons, whereas negatively charged particles, they are represented as electrons, which means that these charges do exist freely in the nature, but their movement is governed by different factors. You might have studied in your plus 2 that the electrons are a little bit free particles when compared to the protons, and they will be moving from one place to another place under the external forces. So, whenever there is a flow of electric charge, then it is referred to as current. So, current is referred to as flow of electric charge. So, in our electrical engineering or in our electronics engineering, we refer electric current as the flow of electric charge through a designated conductor. So, whenever you take a conductor is any material which freely allows the movement of charges. So, I'll take a conductor. It is just a medium. So, if it is allowing free charges, or if it is allowing the charges freely to move, then it is generally considered as a conductor. So, the movement of charges in this medium is referred to as electric currents. This medium can be in the form of a wire. Most of the times we will be using copper wires or aluminum wires. You might be seeing them, right? So these are considered to be conductors, good conductors. So, electric current, it is represented by the symbol I, right? We will be using different letters for representing I. Once I'll be using smaller case, sometimes I'll be using bigger case, uppercase. So generally a smaller case represents it is an AC value, whereas a uppercase generally represents a DC value or an instantaneous value. Okay. So anyways, current is represented with the with the letter I, and it is measured in amperes. And the true definition of electric current is the rate of flow of electric charge. I is rate of flow of electric charge. So if charge is represented by Q, then I is equal to dQ by dt. The rate of change of charge. If this is constant. If it is constantly varying, then I can directly take it as q by t. If the slope is constant, then I can go with this formula, I is equal to q by t. But general definition is I is equal to dq by dt. Got it? And current, one more thing which to discuss about the current is, current basically is intertwined with the direction. Generally, we basically consider that current is a movement of electrons. But coming to the direction of electric current, it is defined as the direction that positive charges should flow. So, conventional current is the direction of positive charges. Whereas electronic current refers to the direction of electrons or negative charges. Okay, so current is basically referred along with its direction and is defined as dq by dt. And moving on to the next common term is electric potential. Electric potential is, now in the last slide I have shown you that you are considering current as a flow of charges, which means that I'll take a wire, the charges are moving from this place to this place, and how they are moving, maybe some external force is driving them, right? So some energy is being spent from moving these electrons to this end, right? So this electric potential energy per electron is called as potential. So how much amount of energy you are putting in to move your electron is basically considered as electric potential. So it is also known as electric potential energy or simply voltage. Commonly we do refer it as electric voltage also, but technical term is potential. So it is a measure of amount of electric potential energy per unit of electric charge in the system. In simpler terms, it is an amount of work needed to move an electric charge from one point to another in an electric field divided by the amount of charge being moved. So whatever the amount of energy or work done by how much charge you are moving, this is considered to be potential. Okay. Generally, it is represented with a symbol of V for DC, and for AC we generally use this particular smaller v, lowercase v, and its units are energy per charge, right? So energy is measured in joules and charge is measured in coulombs, or sometimes you can directly take it as volts. And truly defined, the electric potential at a point in an electric field is measured relative to a reference point. Generally, that reference point is taken as an infinity, where the electric potential is considered to be zero. Let us suppose if there is an electric field here. Every point will be having some potential, right? So at that point, let us suppose if this is V1, this is V2, this is V3, this is V4. All these points do have potentials, and they are referred with respect to some infinity. This is the amount of energy done. This is V1. This is the amount of energy done. This is V2, amount of energy done. This is V3. This is amount of energy done from moving a charge from infinity to this point. Now let us suppose if you are moving between these two, then what I should do? The potential between them is V2 minus V1. And this is called as potential difference. Right. And electric energy. The third term is electric energy. Electric energy refers to the energy that is being carried out by electric currents, which are the movement of charged particles through a conducting material. And this energy can be used to power devices, machines, and electrical systems, etc., isn't it? So whatever the energy, because your current are nothing but, they are nothing but charges which are moving freely, right? So whatever the energy which they are carrying, it is referred to as electrical energy. Normally it is measured in terms of joules or watt hours. You know that law of conservation of energy. Energy is available in different forms. Normally available form is heat energy, light energy. So all these types of energy, they can be converted into electrical form. So you do have different devices which convert these different forms of energy into electrical energy. Electrical energy is easily transportable and can be converted into other forms. So that's fine. We generally choose electrical energy as our medium. And this electrical energy is basically converted to again heat, light or mechanical energy based upon our needs. So you take at our home whatever our requirements. If I do have a fan, if I want my fan to blow air on me, then it means that it is supposed to provide some sort of kinetic energy such that I will enjoy it. Let us suppose if I want light in my room, my electric bulb should emit light, which means it takes electrical energy and emits light energy. If I turn on AC or if I turn on heater in my room, which means electrical energy is being converted into heat energy. So whatever the electrical energy which you are generating somewhere in different plants, it is transmitted and then again it is converted into different forms based upon my requirements. So electrical energy truly refers to the energy which is carried by electric currents. Again it is converted into different modes based upon our requirements. So how the electric energy is generated? That is a different mechanism which we will discuss in unit number 4. How electrical energy is generated. It is not really generated, it is converted from another forms to electrical energy, transmitted to desired place. Again here it is converted into other forms. So I hope you have understood why electrical energy and what is the significance of electrical energy. The next is electric power, the other term, which is referred to as the amount of energy transferred per second or the rate at which electrical energy is transferred. So power is generally represented by capital P. There are other types of power also, active power, reactive power, complex power, that we will see in the unit number 2. But right now I am referring it as P, which is the rate at which energy is transmitted. So dW by dt, or I'll take it as dE by dt, where E refers to energy. So it is joules per second, or I can use it as watts. Often it is referred in kilowatts. So it is the amount of energy which is consumed or produced, anything is okay, in a given time. And yeah, this is the common terms. One is the current, the next one is the voltage, the next one is the energy, and the next one is power. And now we'll discuss about what actually is an electric network or a circuit.